Hello, everyone, and we're going to go over the review sheet today. And remember, your job today also is to resubmit the review sheet with any changes. If you got 100 already, you can just resubmit it onto here, just post another copy. If not, just make any changes. If you want to start fresh and do it over, you can, but it's up to you. So let's jump into it. Number one, Tori is training for a CrossFit competition and she lifts 10 pounds the first week and increases her weight by 8% each week for her training program. Using a geometric series formula, find the total number of pounds Tori lifts over the first 12 weeks of training to round it to the nearest thousandth. Now, a couple things. It's not saying find how much she lifts in week 12, it's saying find the total number. Okay? Total number. So, we're going to use the geometric series to find the sum of the first 12 weeks. Now, this formula is pasted here because it is a reference sheet formula. You get this formula, it's not something you have to memorize. So, let's see. The sum of the first 12 weeks. Well, a couple of things. We know the initial amount she lifts is 10. We know the rate at which it's going up is 1.08. And n, we're looking for 12 weeks. Sum in the first 12 weeks. So the sum in the first 12 weeks equals a sub 1 minus a sub 1 to the r to the n over 1 minus 1.08. Okay? And we go into the calculator. We type this in. Let's see. 10 minus 10 parentheses 1.08 raised to the 12th. Make sure you put that whole numerator in parentheses and divide it by 1 minus 1.08. So in total, she has lifted about 189 pounds because it goes up 8% per week. So the sum of the first 12 terms rounded to the nearest thousandth, tens, hundredths, thousandths, is 189.771 pounds. Number two, using the recursive sequence stated below, find the next three terms of the sequence in simplest form. So the first number is 2, and then define each term, take the term before it, raise it to the negative third, and multiply by 2. So be careful here. It's not minus 3. It's raised to the negative third. So a sub 1 is 2. That means a sub 2 is 2 times 2 to the negative third, which you could just use your, you could do it without it, right? If we want to do without it, let's see, it's 2 times 1 over 2 to the positive third, which is 2 times 1/8, which is 1/4. The other way, again, just do it in the calculator. It's not a problem. Let's see, 2 times 2 raised to the negative third, 1/4. And now, the third term, 2 times 1/4 raised to the negative third. Let's see, 2 times 1/4. You know what? I should put that in parentheses. 1/4 raised to the negative third is 128. And then the fourth term is 2 times 128 to the negative third. This will probably be a scary number. Let's see. 2 times 128 raised to the negative third. And there you go. And you could just write that. 576. There you go. Okay. Now, numbers 3 through 6 state if the following is arithmetic or geometric, and based on your answer, state the common difference or common ratio, and then write the recursive and the explicit formula. All right, so recursive, right, we've seen is when you have to state the first term and then state what's happening to each term. So here, I already went ahead and did this. It's geometric. It's multiplied by negative 0.5. It's getting half a small n, flipping alternating signs. That's multiplying by a negative number. So recursive, the first term is 20. And to find each term, right, you take 20, multiply it by negative 0.5. Oh, that's not correct. Sorry. The first term is 20, And then to find each term, it's negative 0.5 times the term before it. Okay? Then, explicit formula. Well, explicit formula is, remember, you can find any term like this. So you get these formulas as well. So this is geometric. So to find any term, take the first term and multiply it by the rate, or the common ratio, which is negative 0.5 to the n minus 1. Okay? Next one is, I made a mistake here, sorry. Arithmetic, and the common difference is you're adding a half each time. So if you want to write recursive first, let's do recursive, right? The first term is 1, and to find any term, you take the term before it and add 0.5. For explicit, okay, to find any term, and that, again, it's right above here, take the first term and add 0.5 and minus 1 times. A geometric sequence whose first term is 4 and fourth term is 8. So we got 4 something something 108. How do I find this? Well, I like to take the explicit formula and plug in what I know. So I'm going to take a sub n equals a sub 1 times the rate to the n minus 1, plug in what I know, and solve for the rate. So to find the fourth term, which is a sub 4, which I'm not going to write a sub 4, I'm going to write 108 equals 4 times the rate to the 4 minus 1, which is to the third. And now I'm going to solve. Divide by 4. Right? That is 27 equals r cubed. Take the cube root of each side. And you get r equals, what's the cube root of 9? 3 times 3 times 3. 3. Okay, a little easier with arithmetic. With arithmetic, the first row of the Nassau Coliseum has 635 seats, and the seats in a row increase at a constant rate. It's addition. There are 715 seats in row 3. Well, how much did it go up? Let's see. 715 minus 635. Not YouTube, sorry. I'm pretty sure that's 80, but let's just take the calculator and be safe. 715 minus 635, it went up 80, and that's in 2 steps, so it's going up, answer divided by 2, it's going up 40 seats per. So 80 divided by 2, 40. Okay, and remember the question still wants us to write it now in an arithmetic and a recursive sequence here, so let's do that. I'm just going to take this and move it over here a little. Sorry. So, recursive. Okay, recursive, take the first term, that's 635, and to find any row, you do the row before, and you add 40. And then explicit, since it's arithmetic, we can go back and we can use this formula here again. Let's take the first term. So to find any term, take the first term and add 40 n minus 1 times. Number 7. A sub 1 equals 20 and a sub n equals 3 over 2 times the term before. So this is geometric because you're taking the term, to find any term, take the term before and multiply by 3 over 2, right? Find the 14th term of the sequence. Now, if you were to do this, that would be kind of terrible because you'd have to find the second, the third, the fourth, the fifth. So this right here, using the recursive, not great. So what we're going to do is we're going to take this and create the explicit formula by using here. So first off, what is the common ratio here? 3 over 2. So, to find any term, it's going to be the first term times 3 over 2 to the n minus 1. So we want to find the 14th term, that's 20 times 3 over 2 to the 14 minus 1. So you're going to take 20 and multiply it by 3 over 2 13 times. And I'm not going to do that by hand. I'm going to do that in the calculator. 20 times 3 over 2 raised to the 13th power. And it's kind of gross. You could leave it as a fraction. You could put it as a decimal. It's up to you. It doesn't matter. I'm going to leave it as a decimal. Fraction. 7971615 over 2048. And the only reason I left it that way is because it doesn't tell me to round. So I'm just going to leave it in that form. You could, as you can see, it's about 3,892. But it doesn't tell me to round, so I'm just going to leave it. Okay. Last two. Number 8. This is a wish, but it's not true. Mr. Nocello is given $10,000 from his in-laws every month for his new baby's college fund. He puts it into a savings account and receives 3% annual interest compounded semi-annually. How much money? Oh, that's another big thing there. That's why I underlined it. How much money will he have in his account after 1 year, right? Rounded to the nearest hundredth. Now think about it. If you keep putting 10,000 in, it's going to keep going up. But it's going to also add together. So it's not saying how much will he have in that month, how much will he put away in that month really, or what it's saying how much will he have collectively. This is a series. You're trying to add together for after 12 months, right? After 1 year, and it's done monthly. So first off, the rate is 3%, but it's semi-annually, so it's actually going up 0.015. So their rate is 1.015. Now I'm going to use our geometric series formula. So after 12 months, let's see, what's the initial amount put in? Let's say 10,000 minus 10,000 to the 1.015 to the 12th over 1 minus 1.015. And be careful putting this in the calculator. It's a lot, but let's see. 10,000 minus 10,000, parentheses 1.015 to the 12th, and that whole thing divided by 1 minus 1.015. $130,412 and 114. So to the nearest hundredth, which is good because it's money, 11 cents. So you get 130,412, 11. Right? And if you think about it, if you just put 10,000 away every month, that would be 120,000 in 12 months. So it's good. It's about another $10,000 in interest. It's pretty nice. It's a lucky baby. Last one. A 3-year lease for an apartment in Long Beach has an annual rent of $45,000 for the first year and will increase by 2% each additional year of the lease. What is the total rent expense? So instead of finding the first, second, and third term and adding them together, again, let's do this as a geometric series. So a couple things that we know. The first year, $45,000. The rate is 1.02 that it's increasing by, and N we're looking for the first 3 years. So the sum you have to pay in the first 3 years, 45 to A sub 1. Let's write the formula again here. Again, I'm not memorizing this. It's right there above me. So to find the sum of the first n terms, you take the first and you subtract the first times the rate to the n over 1 minus the rate. So we get the sum of the first 3 years is 45,000 minus 45,000 times 1.02 to the third over 1 minus 1.02. Just again, be careful putting this into the calculator. Let's do it. 45,000 minus 45,000, parentheses 1.02 cubed. Put that whole thing divided by 1 minus 1.02. And you will pay collectively in 3 years of rent $137,718. Don't worry about the 0.00000000026. It's money, and I think that's just calculator error, but there you go. Okay.